So बच्चों, those were two questions for today from calculus. Definitely पहला क्वेश्चन आपका definite integral का है. It's on estimation of integral. See, I strongly believe we don't have the tools right now to solve this integral. So as you can see, the options, the value of this integral lie in the interval. So it's basically on the estimation of the integral. Second one is direct question on limits. Okay, let's start. So see, first question is, so I found it to be a very good, very interesting question because of the approach to solve this question. So it's 8 sine x minus sine 2x upon x. Okay, we have to estimate its value. Now see, what I will suggest here is, I will say, okay, let us take one function f of x to be 8 sine x minus sine 2x. Okay, not differentiated. Why am I doing it? You will realize it. Just wait for a few moments. So it's 8 cos x and then minus 2 cos 2x. Fine. Okay. So can we say anything about the sign of this function? So I don't think, because see, let's simplify. So you simplify it. So you take 8 cos x minus 2 into 2 cos square x minus 1. So basically you take 2 common. So it's rather take minus 2 common. So you get 2 cos square x. Okay. Minus 4 cos x minus 1. Now its discriminant. Its discriminant is positive. So that means it changes its sign. It changes its sign. Okay, because positive means it need to have real roots. Real roots means it will change the sign from somewhere from positive to negative or negative to positive. We should also check one more thing, whether the roots are in the range of minus 1 to 1 or not. That you can easily check here, bachon. Okay, that you can definitely check here. But what I'm saying is it changes sign. So now I will go for f double dash x, because once you go for f double dash x, you get it as plus 4 sine 2x. Okay. Now you simplify it. Take 8 sine x common. You have minus 1 plus cos x, and which is for sure less than or equal to 0. So what does that mean? That means from here we can definitely claim f dash x to be a decreasing function. So one thing is for sure, is a decreasing function. So now our interval of concern is pi by 4 to pi by 3. So since f dash x is a decreasing function, therefore I can write f dash x will be less than or equal to f dash pi by 4. Isn't that? Decreasing function. So at the left end of the interval, it need to have the maximum value. At the right end of the interval, it need to have the minimum value greater than f dash pi by 3. Now how much is f dash pi by 3? Okay, so f dash pi by 3 means 8 cos, and this is 5. Okay, less than equal to f dash x, less than equal to f dash pi by 4. So pi by 4 is 8 by root 2 is 4 root 2, and cos 0. Okay, so it's 4 root 2. Now integrating both all the sides. See, we can definitely integrate the inequality. Okay, you can't differentiate an inequality, but you can definitely integrate. Definitely integrate means you can apply definite integration over an inequality. So integrating it in the interval 0 to x, what do we get? So 0 to x f dash x, of course, is integral would be fx, isn't that? So 4 root 2 0 to x dx. Okay, so what does that give us? That gives us 5x is less than equal to, see, fx minus f0. Now our fx is this, so f0 is 0 coincidentally, so this remains as fx less than equal to 4 root 2x divide by x here. So 5 is less than equal to fx by x is less than equal to 4 root 2. Now integrate in the required interval, bachcho. That's it. So that gives us I. So it gives you 0 pi by 4, 2 pi by 3, 4 root 2 dx. That's it, bachcho. So hence you get this as the answer. So that should be the answer that you can easily check it. Okay. So that was a nice question because of this approach. So I really found it to be a very good question. That's why I shared it here. Now let's move to the next one. Next one is a limit. See, got it as a doubt today itself. So I thought to put it in front of you. See, it's not a difficult one, but see, my simple approach was if I have to solve this limit, I couldn't think of anything else while taking it, solving it as a doubt. So what I tried as the first step itself, see the very first step, I definitely tried to solve it using rationalization of the numerator, but that didn't help because both the terms separately are approaching zero. Okay, so if you take its conjugate, that's also going to zero. So that one didn't help, according to me. You may try it that way also, but then I didn't proceed. I then thought to open this series here, bachcho. So 1 minus x plus x square by 2 factorial minus dot 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 and whole raised to the power half. Similarly, minus times 1 minus cos 1 minus x square by 2 factorial plus x is power 4 by 4 factorial minus dot 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 all is power half, and then you all know we can approximate that you can do it with the help of this thing also. You can approximate root sin x by root x when x is quite close to 0. We all know this. You had been using it quite often in physics, isn't that? Now when you solve it, you get rid of it, you get root x common from the first bracket, and you have 1 minus x by 2 factorial plus x square by 3 factorial minus dot 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 within square root minus you get x common, and that's it from the second bracket. Okay, you get x common, it's 1 by 2 factorial, and then whatever you are left with, it doesn't matter, minus x square by 4 factorial and plus dot 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 whole within square root, and you have root x. Now just take root x common from everywhere. So this and this get cancelled. You are left with x. And when x approaches 0, everything else goes to 0 except this one. So answer should be 1 here. Okay, so those were two questions from calculus for today, bachcho.